Welcome to new session of the differential equation. In this session, we will discuss about exact differential equation. As we all know, a differential equation is exact if it can be derived from the primitive, that means the solution of a differential equation, and it can be derived from the primitive directly by the differentiation without any subsequent multiplication or elimination. That is, the differential equation of the form m of x y dx plus n of x y dy is equal to 0, we just put it as equation number 1, is exact. That is, here we have a function m is a function of x and y, as well as here we have another function n that is also a function of x y. That this kind of differential equation 1 is exact if there exists a function u of x y, that is a function in x and y, such that m dx plus n dy is equal to du. M dx plus n dy is equal to du. That is, a differential equation of the form in equation 1 is exact if there exists a function u of x y such that m dx plus n dy is equal to du. Here m, n and u are all functions in x and y. See, we can have an example. In this example, we just say find exact differential equation, find exact differential equation, find exact differential equation that have x square plus y square is equal to c as a general solution, as the general solution. So, we have to find a differential equation that should be exact. If it can be derived, that is x square plus y square is equal to c, as we just said before, that is, we can derive a differential equation from this primitive, this is the primitive, this is the general solution. So, this we can differentiate this given equation. I would like to write this as equation number 1 as part of solution. I would like to write x square plus y square is equal to c is the equation number 1. So, just differentiate 1 with respect to x. Okay, we differentiate 1 with respect to x. So, we will have 2x plus 2y into dy by dx is equal to derivative of arbitrary constant is equal to 0. See, from here we can write this as we can take 2 outsides. So, we have x plus y into dy by dx is equal to 0. So, we can rewrite this as x plus y into dy by dx is equal to 0. Okay, we can write this as, we can take this is y into dy by dx into right hand side. So, we will have x is equal to minus y into dy by dx. Okay, we can take this dx to be here in LHS. So, we will have x dx is equal to minus y dy. Okay, we can take minus y dy into LHS. So, after all, we will have x dx plus y dy is equal to 0. See, now we have an equation. From this equation, we can say that we have an equation. Here we will have this is m. See, here we will have this is m dx and n dy, this is n. So, this is the differential equation where the solution, whose general solution is x square plus y square is equal to c. We all know about x square plus y square equal to c. That is the equation. This equation will be the concentric circles in plane. So, we can say that this is the exact differential equation corresponding to that solution. So, in this session our discussion is that how can we solve exact differential equation. As we said before, we have m dx, m is a function of x and y, and n dy n dy is equal to 0 is the differential equation. We have to check whether this differential equation is, whether it is equation number 1 is exact or not. Here we are, as we said before, m is a function of x y and as well as n is a function of x y. So, we have to check whether this differential equation is exact or not. And then our thought is that if it is exact, how can we solve this differential equation? How can we find the general solution of this differential equation? Suppose if it is not exact, how can we make this a unexact differential equation? Then we will solve how the exact differential equation will solve. Okay, see, so as we said before, we said before, we all know this is there should exist a function, there exists a function u of x y, okay, such that there exists this function mtx plus n dy is equal to m dx plus n dy is equal to du This is equation number 2. Say we since u is a function of x and y, we have du is equal to dou u by dou x, du is equal to dou u by dou x into dou u by dou x into du, dou u by dou x into dx plus dou u by dou y plus dou u by dou y into dy. So, since u is a function of x and y, we can write du as like this, dou u by dou x into dx plus dou u by dou y into dy. So, I would like to put this as equation number, I would like to put this as equation number 3. So, while comparing equation number 2 and 3, we have du, here we have du is here in RHS and we have m dx, but here we have dou u by dou x m dx plus dou u by dou x into dx. So, we have m dx and here we have dou u by dou x into dx is there, and similarly we have n dy is there, but here we have dou u by dou y into dy is there. So, from there we can find it is that this is equal to m is equal to dou u divided by dou x and n is equal to dou u divided by dou y is there. M is equal to dou u by dou x is there, n is equal to dou u by dou y is there. So, from there we can have dou m by dou y is there. From there we can say that the dou m by dou y, dou m divided by dou y is equal to, see, m is equal to dou u by dou x. So, dou m by dou y is equal to dou u divided by dou x dou y is there. Similarly, we have dou n by dou x, is there. Dou n by dou x we already know it is that n is equal to dou u by dou y is there. So, we can say that dou n by dou x is equal to dou u divided by dou y dou x is there. Okay. So, we can say that the differential equation is exact, that means we started from equation number 1, from here from 1 we can say that the equation number 1 is exact if there exists 2, and corresponding to we will have the equation 3 is here. From here we found it is that m is dou u by dou x and n is dou u by dou y. And we can say that this is exact if dou square u divided by dou x dou y and dou square u divided by dou y dou x are equal. So, equation 1 is exact equation 1 is exact if dou square u divided by dou x dou y is equal to dou square u divided by dou y dou x. That is equation 1 is exact. Equation 1 is exact. Equation 1 is exact if dou m divided by dou y is equal to dou n divided by dou x. Okay. Dou m divided by dou y is equal to dou n divided by dou x. See, dou m by dou y is equal to dou n by dou x, then we can say that the given differential equation of the form m dx plus n dy is equal to 0 is exact. See, as we said before, we can generate a differential equation of the form m dx plus n dy is equal to 0 from the primitive, from the solution of a differential equation. Similarly, as well as we can say that if we have a differential equation of the form m dx plus n dy is equal to 0 is exact if it can be if dou m divided by dou y is equal to dou n divided by dou x. So, we can move to some examples. See, in example 1 check whether the differential equation xy square x dx xy square plus x dx xy square plus x dx plus yx square dy plus yx square dy is equal to 0 is exact or not, is exact or not. So, we have to check whether is this differential equation is exact or not. Here we have the differential equation, given that the differential equation xy square plus x dx xy square plus x dx plus yx square dy is equal to 0 is the equation number 1. Okay. From here we can write this as this is the m dx, this is m and this is n. Okay. So, as we said before, we can say that the given differential equation of the form m dx plus n dy is equal to 0 if dou m by dou y is equal to dou n by dou x. Okay. So, we can write this is m is equal to, here we have m is equal to xy square plus x and n is equal to yx square. Okay, fine. So, we can say we have to check whether the dou m by dou y is equal to dou n by dou x. Okay, we can find dou m by dou y. Dou m divided by dou y is equal to, we can write this is equal to x into derivative of y square, that is 2y, that is equal to 2xy. The derivative of x 0 because we are differentiating partially. Okay. Similarly, we have to check whether we have to find the value of dou n by dou x. Okay. Dou n by dou x. Here we have yx square. We are differentiating partially with respect to x. So, that we can write this is equal to 2xy or 2yx. So, from here we can say that dou m by dou y is equal to 2xy. And similarly, dou n by dou x is equal to 2xy. So, that we can say that this is the differential equation 1 is exact. Since dou m divided by since dou m divided by dou y, since dou m divided by dou y is equal to dou n divided by dou x is there. Therefore, the equation 1 is exact, that is the given differential equation is exact. That is the differential equation is exact. That means xy square plus x dx plus yx square dy is equal to 0 is an exact differential equation. Say we can move to one more question. in example 2 just write, check whether the differential equation, check whether the differential equation, check whether the differential equation check whether the differential equation cos y dx, sorry, check whether the differential equation cos y dx plus y square minus x sin y dy, y square minus x sin y dy, y square minus x sin y dy is equal to 0 is exact, sorry, is exact or not. See, from here we understood it is that this is m, okay, and similarly here we have this is, sorry, this is n, okay, fine, okay, fine, we have m is there and n is there. So, we have to find dou m by dou y. Dou m by dou y is the derivative of the cos y, because only the terms of y, the function with y only is there. Therefore, the partial differentiation is as like the ordinary differentiation. Therefore, this is the dou m by dou y is equal to derivative of cos y, that is equal to sin y. And similarly, have to find dou n divided by dou x. Similarly, we have to find dou n divided by dou x. So, we have while finding dou n by dou x, we are differentiating n partially with respect to x. Therefore, y is a constant, that will be 0, and here we have x sin y is there. So, here we have derivative of x is there, that is 1. Therefore, sin y is there, minus sin y is there, because here we have a minus sign. So, dou m by dou y is minus sin y, dou n by dou x is also minus sin y. Therefore, we can say that, okay, therefore, dou m divided by dou y is equal to dou n divided by dou x. Hence, the given differential equation is exact. Therefore, the given differential equation cos y dx plus y square minus x sin y dy equal to 0 is exact. Therefore, the given differential equation 1 is exact. See, I would like just to move to in example 3, that is we can again move back to example 2. Here we have cos y dx is there, just I would like to write cos y dx plus, see, y square minus x sin y dy. So, I would like to write sin y square plus x sin y dy is equal to 0. Okay, I would like to write this is equation number 1. From here we have this is m, cos y is m and this is n. Okay. So, while finding dou m by dou y, as we done just before, it is derivative of the cos y, therefore, minus sin y is there. See, while finding dou n divided by dou x, we are differentiating n partially with respect to x. See, y derivative of y square is 0 and derivative of x sin y, derivative of x is 1, here we have plus sign, therefore, sin y is there. See, dou m divided by dou y is the minus sin y, and similarly, dou n by dou x is plus sin y. So, just only sign is different, even though the different dou m by dou y not equal to dou n by dou x. Okay. Therefore, we can write this is equal to, that is dou m divided by dou y is not equal to dou n divided by dou x. Okay. So, therefore, the given differential equation, one is not exact. Okay. So, we have differential equations of the form. While calculating differential equation m dx plus n dy equal to 0, we have differential equation of the form maybe sometimes dou m by dou y is equal to dou n by dou x, that is the exact differential equation. There may be some differential equation of the form m dx plus n dy equal to 0, even though dou m by dou y is equal to dou n by dou x, that is not exact. So, but maybe such non-exact differential equation can be converted into exact differential equation by multiplying some function. Such functions are called the integrating factors. See, my dear students, we can just move to how can we solve an exact differential equation. How can we solve an exact differential equation? So, write down the next question. Solve the differential equation or find the general solution of the differential equation 2xy minus 3x square dx, okay, minus 3x square dx plus x square minus 2y dy is equal to 0. This is equation number 1. Okay. So, while calculating from here, we have this is the differential equation of the form m dx plus n dy equal to 0. So, we have to check whether this is exact or not. So, we have m is equal to 2xy minus 3x square. Similarly, here we have n is equal to x square minus 2y is there. See, have to find dou m by dou y. While finding dou m by dou y, we just partially differentiate m with respect to y. So, here we have x square term is a constant term, will be 0. So, we have to consider only 2xy. So, while partially differentiating this one, we will have this is equal to 2x. This part will be 0. Similarly, dou n by dou x is equal to, we have to partially differentiate n with respect to x. So, that we will have derivative of x square is equal to 2x, derivative of 2y is 0. So, while we found dou m by dou y and similarly dou n by dou x, both are equal. Dou m by dou y is equal to dou n by dou x. Therefore, the differential equation 1 is exact. The differential equation 1 is exact. See, we found the differential equation 1 is exact. Now, this is a exact differential equation. Our thought is that how can we find the solution u? So, we have the solution u of x y is equal to c. Okay. The solution u of x y is equal to integral of m of x y dx plus a constant of integration. Integral of m of x y dx plus a constant of integration. The constant of integration here we are integrating with respect to x. Therefore, the constant of integration is a function in y, okay, g of y. See, we have integral of m of x y dx, that is equal to integral of, see here we have integral of m of x y dx. See, 2xy minus 3x square is there. So, this is equal to integral of 2xy minus 3x square minus 3x square dx plus g of y. Okay. So, from here we will have this is equal to integral of 2xy with respect to x. So, this is equal to 2x square y divided by 2 minus 3 x cube by 3 plus g of y is there. Okay. We just integrate 2xy with respect to x, therefore, we can cancel 2 and 2 and similarly 3x square is there. We just integrating x square as x cube by 3. So, we can cancel 3 and 3. Finally, we will have x square y minus x cube plus g of y is there. This is the function u of x y. Okay. This is a function u of x y is there. So, we have to find dou we can find dou u by dou y. So, evaluate dou u by dou y, dou u divided by dou y is there. Just like would like to take your attention to previously, here we have n is equal to dou u by dou y. So, here we have dou u by dou y is equal to n. Here we have dou u by dou y is equal to dou u divided by dou y is equal to n. See what is actually here we have u of x y is there. So, we can find dou u by dou y. So, we can partially differentiate this is I would like to put this as equation number 2. Okay. I would like to put equation number 2. So, dou u divided by dou y we can partially differentiate with respect to y x square y as with respect to y. So, we partially differentiating x square y with respect to y, therefore, we will have x square dou u divided by dou y is equal to x square is there. So, x minus we we partially differentiating this one x cube with respect to y. So, that is equal to 0 that is equal to 0 and we partially differentiating the g of y. G of y means the function of y alone. So, if you are partially differentiating with respect to y the function of y alone, that is just only differentiate. So, we have g dash of y is here. So, this is actually equal to n. What is n? That is equal to that is x square plus g dash of y is equal to, see what about n? The n is actually x square minus 2 y is there. So, this is equal to x square minus 2 y. This is equal to x square minus 2 y is there. So, from there we can say that this is equal to we can cancel x square and x square. Finally, we have that is g dash of y, sorry, that is g dash of y is equal to g dash of y is equal to minus 2 y. Okay. G dash of y is equal to minus 2 y. Therefore, we can integrate with respect to y. Therefore, integral of g dash of y dy is equal to minus integral of 2 y dy is there. Sorry, minus integral of 2 y dy is there. So, we can say that integral of g dash of y, that is equal to g of y, sorry, that is equal to g of y is equal to integral of 2 y, that is equal to 2 y square by 2, that is equal to 2 y square minus 2 y square by 2 is equal to minus y square. Therefore, we found the value of g of y as minus y square. Okay, we already found the general solution as x square y minus x cube plus g of y. Okay, so instead of g of y we can replace this as, okay. So, we found, so we have u of x y is equal to x square y, okay. We found u of x square y minus x cube plus g of y minus x cube plus g of y. So, instead of g of y we can write minus y square is equal to sum C1. Okay. So, is equal to sum C is there, is the general solution of the given differential equation, is the general solution of the given differential equation. So, my dear students, while if you go through in many literatures, you can find many questions of the exact differential equation. This is a very nice part of the differential equation. I would like to give you some assignments. Solve the differential equation, solve the differential equation y dx plus x dy is equal to 0, y dx plus x dy is equal to 0. Secondly, write down 2x plus e raised to y dx 2x plus e raised to y dx plus x e raised to y dy is equal to 0, x e raised to y dy is equal to 0. Okay. So, you can find many questions, try to solve the questions of the exact differential equation. Okay. Thank you for watching these videos, continue your watching, thank you very much.